In this video, I'm going to go over graphing a piecewise defined function, problem type number 3. Okay, so here's the first one I got. Suppose that the function f is defined for all real numbers as follows. Let me copy it down, or at least look at this function. F of x equals, I'm going to look at the first top piece, which is negative 10 plus x squared. Can I just switch the order and write it as x squared minus 10? Then we know this is a parabola, because remember we talked about quadratic functions and transformation in section 1.7, 1.6. We know this is a parabola that's been shifted down 10 units. Okay, shifted down 10 units, right? But it's going to be a regular parabola. There is no leading coefficient multiplied to make the shape skinnier or wider. It's just a good regular shaped parabola. But I know it's going to be shifted down 10 units because of that minus 10. But this is a piecewise function, so it's not going to be a parabola everywhere. We need to look at the domain. It said use this if x is in between negative 4 and positive 4. Okay, so what I will do is I will just plot 2 points that is to the left end of this parabola and to the right end of this parabola. So if I plug in negative 4, what will I get? The rule is to square and subtract 10. So if I square negative 4, that's 16. Subtract 10, that is 6. I will go ahead and plot, hold on. What kind of circle? Isn't that a good question? What kind of circle do you want to plot? And because it says x is greater than or equal to negative 4, I'm going to plot a closed circle because of that bar underneath. Closed circle at negative 4, 6. Because negative 4 is the x value. 6 is the y value. Let me go ahead and plot that, okay? Negative 4 and 6, a closed circle. Click on this, 4 to the left, up 6. Stop. And then I'm back here, and I'm going to go ahead and plot the other boundary point, which is positive 4. So plug in 4 in here, and then let's go ahead and calculate the y value. 4 squared is 16. 16 minus 10 is 6 again. But this time we're going to plot an open circle. Why do we plot an open circle? Because look, this green highlighted inequality says x is less than 4. It's not saying x is less than or equal to 4. Because it's simply less than 4, we are going to use an open circle. Plot an open circle at 4, 6. Let's do that, okay? Plot an open circle at 4, 6. 4 to the right, up 6. And what I will do is I will go ahead and draw a parabola at the origin. But guess what? I'm going to, oh no, it's going crazy. Let me try again. But this parabola will, let me zoom in for you guys, okay? What happened to my dot? I see what you mean by you guys were getting frustrated with the tools over here. Okay, I got those dots plotted, but I'm about to fit my parabola starting at the origin because there was minus 10 after x squared. I'm going to shift it down 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I will hit, oh, something doesn't look right. And I'm trying to figure out where I went wrong. Because if I plot a point right here, oh, okay. Choose how the curve opens. That's how I want it to open. Because I wanted those points to go through that solid dot and open dot. I just had to click on it. It says place another point. I know the other point is going to be at 4, 6. Okay, so I was able to do it. But I don't need the one that's going past 4 to the right. and that one that's going past -4 to the left. So what I'm seeing is there's a scissor function. Maybe I can cut this one. They said plot a point to, this is little too much, guys. Hey, I will do this. They said enter a point where you would like to cut the graph. Plot the point to edit graph. I want them to cut my graph at -4 and 6. Let's see what they do. Cut it over there. Cut it. Oh no, cut it. Cut the damn thing. Ugh. How about I want them to cut it at 4 and +6, and I click on it. And are they gonna let me cut it this time? Cut it. Cut it. I may have to ask Helena, how did you do this? Maybe I can draw the, oh, hey, it works. Look at that, guys. I'm just learning these tools as I go. I'm gonna click on the eraser button and take a look. I can just go this area and I will click this. That's gone now. I will click this. It's gone now. That is perfect. That is perfect. I wonder if there's a way for me to get rid of this, cross sign. But that is good enough. That is good enough. So we graphed a parabola. I used the scissor function. That was super cool. So when I click on the scissor function, they wanted me to enter the boundary points where I had that closed circle and the open circle. And then after plotting them, I used, hey, let me show you. This was way too cool. Let me show you. So this is, let me try again. So I think you are okay with plotting those points. You know how I got those special points. I plugged in left bound and the right bound of this parabola. And what I did was I grabbed the parabola tool and I went down 10 and I clicked on it. Because the vertex is at 0, -10. Because this was shifted down 10 units. I clicked on it. They said choose how the parabola opens. This way? No. It has to open upward because there is no negative in front of x squared. So I clicked on it again and they said place another point. So I know the next point, and you can click on either this one or that one, doesn't matter because parabola is perfectly symmetric. So I just clicked on one of those dots that we plotted by hand. Click. And then here is me thinking, I only want this cup shape in between closed circle and this open circle. I don't want them to stick up to the right and left of it because, that area is outside -4 and +4. So we needed to delete those. So I clicked on the scissor function and I said, hey, I want you to cut this at -4 and 6, enter. And I can use the eraser function and click the other side that is outside of -4. That's gone. And I can click on the scissor function again and type in 4 and 6, plot point to edit graph. And then I use the eraser function again and click this area. Beautiful. Now I am halfway done, you guys, but I'm sure that's the hard part. That was the hard part. Let me now work on the second function. The second piece, we're still looking at the same function. So the second piece says 12 minus x if x is greater than or equal to 4. So if you are okay with me erasing this one, I'll just move that down. I am ready to do the second piece. I'll do XY table and I need to plot that 4. Okay, what happens if x is equal to 4? Let's see. If I plug in 4 into the function, which is 12 minus x, I get 12 minus 4, which is 8. Will you plot an open circle or a closed circle? Look, because it says greater than or equal to, we need a closed circle. At 4, 8. So that's the x value and the y value. So let's plot a closed circle at 4, 8. Because this is a linear function, I need another point for the direction of this straight line. How about I just randomly do a 5? Why? Because they said X has to be greater than or equal to 4. So 5 is perfectly fine number. If I do 5, 12 minus 5 will give me 7. So the next point on this graph will be 5, 7. No wonder you guys were having issue learning these tools because it wasn't your graphing skill. It was really graphing on this specific, graphing on ALEKS, using these tools. All right, let me plot 4, 8 with the closed circle, okay? 4 to the right, up 8, dot. And then I will use a ray, okay? You know what a ray is from geometry class. Ray starts at one endpoint and go forever to only one direction. So here's the ray button. I will click on this, but I forgot what was the second point that we needed to plot. The second point was, look, 5, 7. So from that point, I will go to 5, 1 to the right, and 5, 1 to the right, and go down 1. And that's perfect because that line does have a slope of -1. And that equation right there, the slope is -1. Okay, I am done graphing this. Let's see. They're asking you a question. Is this function continuous? No, it's not, because this U shape is down here and this straight line going down and this open circle, they're not on top of each other. We cannot graph this function without lifting our pencil. Let me go ahead and click on check. It better be right? Yay! So that is good. So I struggled a little bit exploring the functions for the first time. So I really appreciate you emailing me about these different technology on your homework. This tech tools, or what do you call it? Tools, just tools. All right, I may be able to do one more. How about one more? All right, this one is another quadratic and a linear. I believe you will get a quadratic and a linear on your problem too. So let me try the quadratic first. It says f of x equals, why do they do this? They flipped it again. Instead of 1 minus x squared, how about I switch the order and write this in standard form and write this as -x squared plus 1. Why did I do that? I want to talk about the transformation. Look, because we have a plus 1, we shift this graph up 1 unit, right? Because it has a negative leading coefficient, we're going to flip this parabola, right? Now, let's see the domain because we need to plot some points. They said use this parabola if x is less than 1. Let me go ahead and plot a couple points on this. If x is equal to 1, what will I get? The rule is to square it. Square it, put a negative in front of it, and add 1. So that will be negative times 1 squared plus 1. So you have to follow the order of operation. You square the 1, which is positive 1, but there is a negative in front of it. So that's back to -1. And we have 0. So I will plot what kind of circle? An open circle, because the symbol is just less than. Open circle at, what are the x value and the y value? 1, 0. 1, 0. I need one more at least, because I remember from the previous problem, they want me to plot another point on this parabola. So I will need to just pick a number that is less than 1, because it says x is less than 1. How about I pick 0? If I plug in 0, I will square 0, put a negative in front of that 0, and add 1. How silly. That is simply 1. I will plot another point of 0, 1. Okay? 0, 1. I'm excited to use this tool again, you guys. So I know the points. Plot an open circle at 1, 0. Open circle at 1, 0. 1 to the right, 0 up. And I'm gonna now use the parabola tool. So remember we said, let me bring this back. The parabola is shifted up 1 unit. So I will go ahead and grab my parabola and make it go up 1 unit, and I will click on it. That's the vertex. They say choose how the curve opens. Because of the negative leading coefficient, we talked about how this graph is going to be flipped upside down. Look, I'm going to go ahead and just bring it down. There we go. I'm going to click on it. And the third one they're asking is place another point. I have another point right here. I will click on this dot, and my parabola is perfect now. But we're going to need to cut it. Remember, this is only true for x values less than 1. So what I will do is I will click on the scissor button, and I will plot my boundary point of 1, comma, I forgot what was the boundary point where we have that open circle. 1, 0. This is some challenging stuff we are doing here, huh? All right, and I click on plot point to edit graph. And what I will do is I will pick up this eraser and I will erase the part that is going to the right side of 1, because x is only allowed to be smaller than 1. So the part, you see how this area right there that's highlighted in yellow, that is going right side of 1. So I will go ahead and delete that. That's looking good now. Let me go and graph the bottom part, the linear function. Okay. Ooh. Okay. The linear function goes like this. Negative 2x plus 2. We use this if x is greater than or equal to 1. X and y, I will plot the 1 and plug in the 1 into this function. That is negative 2 times 1 plus 2. And that is negative 2 plus 2, which is 0. I will plot a closed, I'm out of room over there. Plot a closed circle at 1, 0. And if you're wondering why a closed circle instead of open circle, look at the symbol for me. That's why it says greater than or equal to. That's why I need a closed circle. Now, I may want another point because it's graphing. It's not just a single point. I need another point. They said, hey, use x's that are greater than or equal to 1. Let me go and use 2 because 2 is greater than 1. Negative 2 times 2 plus 2. That is negative 4 plus 2. That is negative 2. So the order pair or the second point that I can plot is 2, negative 2. I will plot that, or I will use that to graph my straight line function. Let us plot 1, 0 with a closed circle. 1 to the right. Let me zoom in. And 0. Hey, look at that. There was an open circle, but when I place my closed circle right there, this function is going to be continuous. I'm going to click on the ray tool. I call it ray tool. I don't know what they call it. But I will start at that point, and then I will go to the next point of 2 to the right, down 2. That was the second point that we were plotting. 2, negative 2. And I click on it, and I am done. And when they ask me the question, is the function f continuous? I can graph this function without lifting my pencil. Therefore, the answer is yes. I click on check. Awesome. 2 in a row. Wow. I now understand why you guys emailed me about this topic. This is a fun little problem. Oh my goodness, another one. This one has 3 pieces. I can do this right now, but it's been about 20 minutes on this video. So, hey, you know what? Maybe you try the other ones, but I think I will come back and record this one too. The reason I am stopping is my baby girl just woke up, so I'm gonna have to go to her because I think this one will take like 10-15 minutes, don't you think? So I will come back and record another video going over this problem, but I hope my phones are ringing like crazy now. But I will stop this video now. I'll talk to you later.